Hi everyone, my name is Gustavo Flores and I'm a customer engineer here at Google Cloud.
And I am Daniel, also a custom engineer at Google Cloud.
Welcome back to the Google Cloud Technical Guides for Startups, where we are creating a series of videos for technical enablement to help startups to start, build, and grow their businesses successfully and sustainably on Google Cloud. In our previous episode, we shared with you how you can get started with compute on Google Kubernetes Engine. Today, we're moving on to compute with Google Compute Engine. We're going to kick off by covering what is Compute Engine. Following that, I'll be going over some common Compute Engine configuration you may want to modify. Then, we'll have a demo of Compute Engine where we'll do the following: show source code in Cloud Shell, create an instance template for your instances, create a managed instance group for your template, deploy an application to the instances running on the managed instance group, and put a load balancer in front of the group so that we can access the application. Then we're going to review a customer success story. So what is Google Compute Engine? Compute Engine is an intuitive and flexible, simple at scale, and secure compute service that lets you create and run your applications on Google Cloud's global infrastructure. Let's talk flexibility. There are 6 different VM families, 3 within the general purpose, and 3 that are optimized for specific types of workloads. General purpose VMs are ideal for a wide variety of applications like web serving, databases, and image processing, and come in flavors optimized for either cost or a balance of price and performance. Workload optimized VMs include compute, memory, and accelerator optimized options for your most demanding applications such as SAP HANA and high performance computing. You can achieve even greater savings through taking advantage of spot VMs. Spot VMs are affordable compute instances suitable for batch jobs and fault-tolerant workloads. Google Cloud Spot VMs guarantee higher minimum savings and more predictability in pricing for spot instances compared to other cloud providers. Let's talk security. Google Cloud and Compute Engine are designed to be secure by default. For enhanced security, you can leverage shielded VMs. Shielded VM features include verifiable integrity with secure and measured boot. Secure boot helps prevent malicious code from being loaded early in the boot sequence. Measured boot ensures the integrity of the bootloader and kernel and boot drivers to guard against malicious modifications to the VM. VTPM exfiltration resistance. You can validate your guest VM pre-boot and boot integrity using VTPM technology, which is compatible with Trusted Computing Group TPM 2.0 specifications. Trusted UEFI firmware. Trusted firmware is based on the Unified Extensible Firmware Interface, or UEFI, 2.3.1, which replaces legacy BIOS subsystems and enables UEFI secure boot capability. Tamper-evident attestations. Gain insight into the integrity state of shielded VMs with tamper-evident attestation claims available in cloud logging and cloud monitoring. These integrity measurements help identify changes from the healthy baseline of your VM and current runtime state. Live migration and patching. Keep your virtual machines instances running even when a host system event occurs, such as software or hardware updates. You can define IAM policies and permissions. You can set these policies and permissions that constrain all new Compute Engine instances to use shielded VM disk images and have VTPM and integrity monitoring options enabled. You can shield existing VM images too. Transform your existing VMs into shielded VMs that run on Google Cloud, bringing verifiable integrity and exfiltration resistance to your existing images. With Google Compute Engine and Cloud TPU, Sensen delivers highly scalable SaaS AI-based solutions across the globe. Sensen's platform analyzes and fuses data from different IoT devices to deliver insights across multiple industries. They said, with Compute Engine and Cloud TPU, Sensen can spin up VMs and configure TPU clusters on demand with minimal effort. And expanding capacity or extending functionality is fast and easy.
I am going to demonstrate how to create a compute engine managed instance group to deploy a simple web application. Docker will be used to build the container images and deploy them in our virtual machines. We're also going to expose our application to the internet by using an external HTTP load balancer. Our sample application is a simple guestbook where visitors can submit messages and clear them. We can perform these steps by both using the Google Cloud SDK in the Cloud Shell or using the Google Cloud Console. Before we get to deploy our app, I will use Cloud Shell to clone the GitHub repo and use the text editor to show you the code. You can find the link to the GitHub repo in the video description if you want to follow along. Let's click the Activate Cloud Shell button at the top of the Google Cloud Console. And we see the Cloud Shell session open inside a new frame at the bottom of the console and display a command line prompt. Let's use this terminal to enter the git clone command and clone the repo. Cloud Shell comes with a built-in code editor that we'll use to read the code. Launch the Cloud Shell editor by clicking the Code Editor button on the toolbar of the Cloud Shell window. Now let's use the left-hand pane to navigate to the code by clicking on the CP100 folder, then App folder, and select the app.py file. As you can see in this Python script, Flask is used for handling HTTP requests for publishing and clearing messages, and Redis is used to save the entries. We also have a Docker file containing all the commands to create the images that will be used to run our Docker containers. I am now going to show you how to create an instance template. Instance templates are a convenient way to save a virtual machine's instance configuration so you can use it later to create a virtual machine or a group of virtual machines. Let's navigate to Compute Engine using the left-hand pane and click Instance Templates. Click Create Instance Template, and it is now time to enter our desired configuration. Let's give it a simple name, Guestbook Server Template. Under the Machine Configuration section, we can see virtual machines are classified by machine family, series, and machine types. For our application, let's select a general purpose E2 medium, which we can see has 2 vCPUs and 4 gigs of memory. Under the boot disk section, we can click the change button to select the operating system and its version, and the disk type and size we want for our virtual machines. Let's add our startup script, which will install Docker, build the image, deploy the container, and expose it internally. Our individual machines don't need an external IP because we will expose the app to the internet using a load balancer. So let's specify none as the external IP. And finally, let's click Create. Now that we have our template, let's use it to create a managed instance group. Managed instance groups lets you operate apps on multiple identical VMs and make your workload scalable and highly available. You can take advantage of automated services, including auto-scaling, auto-healing, multiple zone deployment, and automatic updating. From the Instance Template section, expand the action menu next to the Guestbook Server template and click the Create Instance Group button. We now see the configuration options for our group of VMs. Let's give this group a simple name like Guestbook Server MID. And we can now decide if we want our VMs to be deployed in one or multiple zones. We will keep this in the US Central 1A zone. Notice we can configure the auto-scaling mode and policy, a minimum and maximum number of VMs, auto-scaling metrics, auto-healing, and other aspects of our managed instance group. Let's go ahead and click Create. Now, if we navigate to the VM Instances menu, we're able to see all the individual machines that are part of our managed instance group. Let's go ahead and check that Docker is running correctly via SSH. Click SSH under the Connect column corresponding to the only instance in our group in the instances list to SSH in a new window. We'll use the command sudo systemctl status docker. In the resulting output, we can see the container engine is active and running our container as intended. Before creating our load balancer, we need to create an ingress firewall rule applicable to the group of VMs being load balanced to allow health checks. Let's use Cloud Shell to create this rule. Notice the two source IP ranges and protocol needed to allow health checks. Now, let's create a configuration by selecting the backend services input box and click the Create a Backend Service button. Let's give it the name Guestbook Backend, and let's choose Guestbook Server MID Instance Group as our backend. Enter 80 for the port number. Our backend requires us to create a health check, so traffic is only directed to healthy machines. So let's select the health check input box and click the Create Health Check. I will name this Basic HTTP Health Check and leave the default values. Let's select our newly created health check and click Create. Now, let's review the front-end default configuration. And we can see the protocol will be HTTP. An ephemeral IPv4 IP address will be assigned, and port 80 will be used. Everything looks good, so we can click on the Create button. Let's review some of our load balancer details by clicking on the guestbook HTTP LB in the load balancers list. And we're now able to use this IP address to use the web application running in our managed instance group. Let's use the browser to visit the application by copying and pasting the IP address and port in the address bar. And here it is, our simple guestbook application. Now, let's leave a short message in our guestbook. Hello, Google Cloud. And we're set. We deployed our guestbook application to a managed instance group and exposed it using a load balancer.
And if after this session you cannot get enough of Compute Engine and are keen to find out more, check out the suggestions here and the links in the description box below. You can read up on Compute Engine, you can check out the Google Cloud drawing board on Compute Engine, or you can try our quick labs on Compute Engine. In our next episode, you'll be learning about Google Cloud's global network. It will cover VPC networking, firewall rules, load balancers, a demo where we'll configure the network for the booking application you saw earlier. Finally, another customer success story. Thank you, and we'll see you in the next video.